Hey class, this is Gigi from Kauai Community College, and we are talking about lesson 20, note handout, example number 6. The question is asking if you have the integral, so if you have the integral from a to x of f of t dt, take the integral and then take the derivative with respect to x, what will you get? Okay, so what I'm going to do is I'm going to write this. My question to you is, why? Can you pause the video and think about why that is? Once you have already reflected, you can see that the integral from the fundamental theorem of calculus, the integral from a to b of f of t dt is going to be f of x minus f of a, where big F is the antiderivative of the little f of t, right? That's the fundamental theorem of calculus. And then what we're supposed to be doing is we're going to go ahead and take the derivative of it with respect to x. So now the derivative of the antiderivative is going to give you f of x. And the derivative of a constant is going to be 0. And as you can see, that is why that is f of x. So there's different explanation. It depends on what someone calls the fundamental theorem of calculus. In this case, I talk about this as our fundamental theorem of calculus. In some cases, people would call this the fundamental theorem of calculus. So it's the matter of the chicken or the egg and which one got proven first. However, the point is if you take the integral and then you take the derivative, it will give you what you started out with, which is the function f, but evaluated at x. Okay, now what does that, what is an application? How does it look like in a problem? Like this. If you're taking the integral from 0 to x of e to the t dt, and then you take the derivative, in short, by this thing right here, the answer is just going to be e to the x. Okay, now in part B, what's going on? X is down there, X is the lower limit. So we are going to have to apply the property of integral to switch the limit. That would give you a negative in the front. So that would be t to the 4 plus 1 dt. So then the answer to this is going to be negative square root of x to the 4th plus 1, and that is it. Okay? Now, what if the upper limit is not x, and the upper limit here is going to be not x, but a function? Well, what do you know about composite function? Well, it is going to be f of g of x multiplied by the derivative of g, because the chain rule is going to apply. Okay, so here we will have, when we're taking the derivative here of the integral from 0 to x squared, well, most people will just think, oh, well, you just take the thing here and put it in, and so you'll get cosine of x squared, which is x to the 4th power. But what you'll forget is you have to multiply by the derivative of g of x, which is 2x. And that is it. Remember, chain rule will apply when you have a composite function.